Hello everybody and welcome back to 2D Vectors, and this is practice video 6. Now in the first question we're given 3 points A, B and C, and we're asked to prove that they're collinear. Now we know that they're collinear if one vector is a scalar multiple of the other vector and they share a common point. So the aim is to find A, B and B, C and compare them. Now we know the vectors OA, OB and OC because we're given the coordinates of A, B and C. For instance, A is minus 1, 4, so OA is minus I plus 4j. And likewise, OB is 2i plus 3j and OC is 8i plus j. Now you can see from the diagram that to get from A to B, we have to go from A down to O, which is in the opposite direction from O to A, and then we can go from O to B. So AB is equal to minus OA plus OB, and this works out as 3i minus j. And similarly, you can see that BC is minus OB plus OC, and BC works out as 6i minus 2j. So from this, you can see that BC is exactly twice AB, and because they share a common point, because they share the point B, they are collinear. Now next we have to find the coordinates of D, but be careful because we're given the ratio BD to BC is 2 to 3. This means that BD to DC is 2 to 1. So to find the coordinates of D, we'll first work out the vector OD. So again, looking at the diagram, you can see that OD is the same as OB plus 2/3 of BC. Now we have all of these values because we worked out BC in the previous section. So putting all the information in, OD comes out as 6i plus 5/3 of j. So D's coordinates are 6, 5/3. We're then told that OB is extended to point P so that AP is parallel to OC, and we're asked to find P's coordinates. Now OP is going to be equal to OA plus AP, and we know OA, but we don't know AP. However, we do know that AP is parallel to OC. So we know that AP is equal to some value times by OC. So it's a scalar multiple of OC. We just don't know what that value is at the moment. So for now, we'll just call it lambda. So now we can write OP is equal to OA plus lambda OC. But we also know that OP is an extension of OB. So OP is going to be some value, which for now we're going to call mu, times by OB. So now we have two different expressions for OP. So we can substitute one back into the other and we get mu OB equals OA plus lambda OC. Now to solve this, we need to find the values for mu and lambda, and to do that we need to form some simultaneous equations. So we're now going to write the vectors in matrix form. Now from here we get these two equations, and if I multiply the first equation by 3 and the second equation by 2, they're both equal to 6 mu. This means that again I can substitute one into the other and eliminate mu completely. So we end up with 24 lambda minus 3 equals 2 lambda plus 8. And we can rearrange that to work out lambda. And if 22 lambda equals 11, lambda is equal to a half. Next, we can substitute lambda back into this equation and we get OP equal to this. And then we need to add the brackets. So a half of 8 is 4 and a half of 1 is a half. So we get minus 1 plus 4 is equal to 3, and 4 plus a half is equal to 9 over 2. So OP is equal to 3i plus 9 over 2j. Now for the next question, we're given one expression and we're asked to prove the second expression. Now we don't know where any of the points A, B, C or P are. However, if we treat A as the origin, we can find alternative expressions for some of the vectors. For instance, we want to find another way to write the vector BP. Well, if we use A as the origin, we can say BP is equivalent to BA plus AP. And likewise, we want to find another way to write PC. And we can say PC is equal to PA plus AC. Then we can substitute those values for BP and PC back into the expression that we were initially given, and then multiply out the brackets to get this. Now here you can see we have a couple of terms with AP and one with PA. Well, PA is exactly the same as AP but in the opposite direction. So we can change 3PA to minus 3AP. Then we can tidy it up a bit by adding all the AP terms together. And then if we move the last two terms onto the right-hand side of the equal sign, we get 2AP is equal to minus 4BA minus 3AC. So it looks like we're getting nearer the proof, but we're not quite there yet. In the proof, there is the term BC. Now, if we look at the diagram, BC is equal to BA plus AC. Now, we could split up our minus 4BA, so we have minus BA minus 3BA. And we could then put that in brackets, so we get minus 3BA plus AC. And you can also see that we've changed the minus BA into a positive AB because they're exactly the same vector but in opposite directions. We can then substitute in BC instead of BA plus AC and divide both sides by 2, so we get AP is equal to a half AB minus 3BC. Well done if you've kept up with that, because this video is definitely harder than the previous videos on 2D vectors. So as always, thanks for watching. Please hit the like button, I'd really appreciate it, and subscribe for more videos like this. I hope to see you soon.